Hello, so today we are comparing two population parameters, but this time we're comparing it with significance tests. So make sure you watched the confidence interval video before this one. This is the significance test video. So this is textbook section 10.1. Once again, look there for more practice problems, the problems from your problem set, etc. So just to review, you've already written this down on the first video, so you don't have to write it down again. I'm just going to recap what we talked about. So we talked about having populations, and we have two different populations, population 1 and 2. But each population has a certain proportion or percent of people or percent of things that meet a characteristic of interest. So there's some true proportion, but I don't know this proportion, so I take samples from each population. So population 1 has sample size 1, population 2 has sample size 2, and from each sample, I get a sample proportion or a p-hat. And this p-hat, like we said, is where I'm going to be doing most of my tests and testing. So instead of using confidence intervals, today we're going to compare two proportions by conducting a significance test for their difference. And this is going to be the null hypothesis, that the proportion from population 1 equals the proportion from population 2. So take out this sheet comparing two group steps. These steps are super important. Everything you need to know about a significance test for two groups is on this sheet. So take this out, and let's review the steps to conduct a significance test. So this should be significance test. So same steps. Step 1, identify the population parameter and my null and alternative hypothesis. So step 1 has the population parameter and my two hypotheses. Step 2 is the same plan step, so we went in depth into the random, normal, and independent conditions for conducting a two-sample test. So go back and look at that first video for the in-depth plan step, but we have to check these three, which we'll do in this video too. The do step, which is where I show my big substitution, and once I have my substitution, I can then use my calculator. And lastly, step 4 is to conclude my conclusion, connection, context. So do I reject or fail to reject? What is the p-value? And use context from the problem. So this is the do step for a significance test for two proportions. So pause the video, write this down, and then we'll go over it. Okay, so now that you paused and you're back, we're looking for the test statistic, or the standardized critical value, or standardized test statistic, and it's always this format. So this is on your formula sheet, statistic minus parameter divided by the standard deviation of your statistic. Well, the statistic is going to be the difference in p-hat 1 minus p-hat 2, which is this numerator right here. The parameter is actually going to be 0 because I think there's no difference in the null hypothesis. So the parameter is 0, which is why you don't see anything right here. You just see p-hat 1 minus p-hat 2 in the numerator. The denominator is the standard deviation of the statistic, which is the same giant piece we had after my confidence interval. So this is the same denominator like my confidence interval had, and this goes everything's under the square root. So once again, you need to know the pieces of this formula, but these individual pieces, especially this denominator, are on the formula sheet to begin with. But like always, your calculator can do a lot of this arithmetic for you once you plug in your pieces. So here are the calculator steps. The first step is to press Stat, then Test. We should be really comfortable with that by now. Stat, then Test. And you want a 2-prop-z test. So the first one was a 2-prop-z int. That was the last video. This is a 2-prop-z test. And the only difference is it wants you to type in the alternative hypothesis down here, not the confidence level. So it wants the alternative hypothesis, and you will shade in whether it's not equal to, less than, or greater than. Also, once you type this in, always try calculate first. If you do draw, you may get an error code. If you do, my main kind of, tip would be to clear your y equals. So if you get an error code when you press draw, clear your y equals and then try again. But if you press calculate, you'll always get the right answer. So let's take a look at this example. This is the same example from the last video, except this time we're doing a significance test, not a confidence interval. So it says, just before the presidential election in November of 2008, a local newspaper conducted a poll of residents in a medium-sized city and found that 120 out of the 250 supported or intended to vote for Barack Obama, and 132 out of a random sample of 240 women intended to vote for Obama. Is there convincing evidence? So this convincing evidence is a key word that says, do a significance test. Is there convincing evidence that there was a gender difference in Obama's support in this city? Support your conclusion with a test of significance using alpha equals 0.05. So if I think about my population and parameter, the population would be all men and women in this city. And the parameter is we want to test a claim about the difference in gender support. For Obama. So for the parameter, once again, I'm not getting creative, I'm just restating what's here. So we don't have to think of something big and crazy, we just restate what was in the problem with the difference of gender support. The next thing I have to do are my two hypotheses, so my null and my alternative. Well, if I think about this problem, and I think about the null hypothesis, the null is always equals. So my null hypothesis is that the proportion from 1 equals the proportion of 2, or if you want to use context, you can say the proportion of men equals the proportion of women. No matter which one you do, you must state that population 1 is the men and population 2 is the women. You have to define who's 1 and who's 2. You can't just write these hypotheses with no definition of who's population 1 and who's population 2. Even if you do this, the M and the W, it's still really good to write this out because the reader on the AP exam needs to see this to give you full credit. The alternative hypothesis is that there is a difference in gender support. It doesn't say greater than or less than, it just says difference in the problem. So the alternative is P1 does not equal P2, or the proportion of men does not equal the proportion of women. So this is my step one, my state. Then I have to do the plan. If you look back on the last problem, we did all of this plan step together. So just to review, random is stated, and it's stated right here with random sample of men and SRS of women. Normal, I have to make sure that N1 times P hat 1 greater than or equal to 5. Well, 250 times 120 out of 250 is greater than or equal to 5 because 120 is greater than or equal to 5. Well, then I'm going to do that again for N2 times P hat 2 greater than or equal to 5. Well, 240 times 132 out of 240 greater than or equal to 5. 132 is greater than or equal to 5. Check. I'm going to do the same thing for N1 times 1 minus P hat 1 and N2 times 1 minus P hat 2. So I checked all 4 of those, and they all 4 work. Now I got to check independence. So independence, we assume they're independent voters. And the population of men is at least 10 times 250, or there's more than 2,500 men, and there's more than 10 times 240 women, so all of those are checked. It may seem like I'm flying through this, but we've done these 3 conditions a lot. So random, normal, independent, the same way of checking it every single time. We should be getting really familiar with this. Because then I get to my do step. And the do step is that formula Z equals P hat 1 minus P hat 2 over the giant square root of P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. So all I have to do is substitute my pieces into this formula, and then I can use my calculator. Well, just to recap, we said P hat 1 was 120 out of 250, which was 0.48, and P hat 2, or the proportion of women, was 132 out of 240, which was 0.55. So I already identified P hat 1, 120 out of 250, or 48%. P hat 2, 132 out of 240. And when I plug this in, I'm going to get 0.48 minus 0.55 divided by 0.48 times 1 minus 0.48 over 250 plus 0.55 times 1 minus 0.55 out of 240. So once I show this, you have to show this substitution right here. Once you have this, we can use our calculator. So 2 prop Z test, X1 and N1 are the men, X2 and N2 are the women. And since it was a different than problem, my alternative is the not equal to. And this is the data that I end up getting. My Z equals negative 1.5 549 or negative 1.55. You can round 2 decimal places. The p is 0.121. So the p-value is 0.121, or 12.1% chance of getting that difference. Well, if I think about the conclusion, I want to write it in context of this problem and in this template. Well, the alpha level was 0.05, and since my p-value is greater than alpha, or 0.121 is greater than 0.05, I fail to reject the null hypothesis claim that the true difference in gender support is equal to P1 equals to P2, or is equal to a 0% difference. So I'm saying I don't have enough evidence to say there's a difference. I could get that difference, that sample difference, 12% of the time, which is greater than my 5% limit. So since P is greater than alpha, I fail to reject the null hypothesis that the true difference in gender support is equal to 0%, or that P1 equals P2. I cannot reject this claim. So essentially I'm saying we don't have evidence that there's a difference. So I already did my conclusion. That was the last slide that would go right here. And that's a wrap. We use significance tests to test a claim about two proportions, and the null hypothesis is always that P1 equals P2. The alternative is where I say greater than, less than, or not equal to. So that's a wrap, and here's the video on significance tests for two proportions. See you next time.